Okay, hello everyone. This is week 4, day 2, and today our focus is going to be on the left, right, and full joins. This constitutes what we call outer joins. So we have inner join and we have outer joins, and these are the three outer joins: left, right, and full. Right. So let's begin with the left join. I have this. I'm going to begin with this PDF document right here. So for the left join, we understand this is how the region looks like. Let me take you back to the main image that has all the join types so you can see. So we are moving away from the inner join, but we see the portion showing up on the left join. You see that? So what has added? The entire left table has added. So when you're targeting a left join, first thing, the sense of direction is very important. For a left join, there's a priority table. So the table you're prioritizing must be placed on the left hand side. If you're doing a right join, you place the prioritized table on the right hand side. So what is the prioritized table? The table in which you're returning all the records from. If you look at the entire left table has been shaded. So every row from the left table must show up in the join. This is very important. And it's always easy to build a left join once you remember that every record from the left table shows up. Right, this is very, very important. Right. So when you're performing a left join, you have to first of all ask yourself what table is on the left hand side. And you just simply have to return all the records from that table on the left hand side. Now, the ones that have matching records, that's the intersection, you list them out. If there's a row on the left hand side which doesn't have a corresponding match on the right hand side, we place a null. Let me show you an example. So yesterday we did this same example with an inner join, right? So the concept of an inner join still applies right here. But if you notice, yesterday we left out 7 and 8. Those two customers did not place any order. But since we are adding a left join, you see that 7 and 8 are showing up. This just tells you that the left table is what the customer's table. And so if you're doing a left join, the table on the left hand side is a prioritized table. So the table immediately after the from clause has a left table. So the customer's table is a table that's being prioritized. You see, we are returning all rows from that table. No question asked. This is very important. That's why 7 and 8, it did not place any order. You see, if I go to the orders table, everything is null because 7 and 8 did not place any order. Now, for every other part that places an order, every other customer, we see the order information right here. So in a left join, you're seeing the intersection, which is like the inner join, customers who place orders, together with all those customers who never place any order. They're on this left hand side right here. Right. So in performing a left join, you have to know what table is being prioritized. The table on the left hand side, you have to make sure you list all the values from that table. Right. Now, let me go back to this. Let's do it the same thing we did yesterday. I'm going to pull up the customers table, pull up the orders table, and show you what a left join looks like. Right. So I'm going to do this in Excel. First, let me connect to what database is that. I think this is a customer insights database. So we have the customers table and the orders table. Right. I'm going to open a new query window and we're going to connect to customer insights. Right. I will just write a basic select statement to return the two tables, and then we're going to copy the data and take it to Excel. And then I'm going to illustrate how to generate a left join. This is very important so that you can see the build process before we go checking out how to build the join. So this is a customers table. I'm going to copy this part and do the same to generate that for the orders table. So these are the two tables right here. So I'll copy this, copy with headers, and just launch an Excel document. And we're going to use this to demonstrate the concept of a left join. Okay, so right here, now let's take this back and put it somewhere right here. So just pay attention. Let's build this concept together. And once it's understood, I think we should be good to go. This is not a good idea. Okay, this looks much better. So what you see right here is a customers table. I'm going to copy the orders table, which is this one, copy with headers. I'm just going to put it next to it somewhere right here. Right. Okay, let me do some adjustments on that. So first thing you see, there's a mutual column, which is what? Customer ID. Right. This column right here, it's also common to this table. So that's the first thing we investigate. Before you do a join, there must be a mutual column between the two tables. That's the column on which we're going to build a join. Right. So now we're looking at the left join. Right. If we are placing the customers table on the left hand side, so give me all customers, irrespective of if they've placed an order or not. That's already an indication of a left join. If you're asked to return only customers who have placed an order, that is an inner join. This is very important. You have to start now knowing when to go for what particular join type. See, if we are asked to list only customers who have placed an order, this cannot be a left join. This is going to be an inner join. But if you're asked to list all customers, whether or not they place an order, so you're going to see those that have placed an order, which is the intersection, together with those that have never placed an order. You see, these two, they've never placed an order. So if a customer has not placed an order, their ID does not show up in the orders table. That's an easy way to investigate that. Right. So there's no customer ID 7 on this list. There's also no customer ID 8. So these two customers have never placed an order. So why are they showing up in this join? Because we did a left join. For an inner join, they will not show up because the inner join is strictly the intersection. I want you to start seeing the difference. Right. So in the left join, if table 1 is a customers table, table 2 is the orders table, this is a list of all customers who have placed an order in the intersection, plus those that have never placed an order. So there are two zones you're targeting. An inner join has just one zone, the intersection. A left or a right join has two zones, those in the intersection and those outside the intersection. So first thing you have to know the table that's being prioritized. So if you want to prioritize the customers table, we are placing on the left side and we do a left join. So let me go back to this Excel document. This is the first thing you do to build a left join. Every record on the left table qualifies. No question asked. You see, we're copying everything from the left hand side. That's the left table, and we put it in the output. This is us trying to build the output. You see, this is one very fundamental thing about a left join. When you're doing a left join, every row from the left table qualifies. It show up in the final result set. There's no condition imposed on the left table. That's why we're calling the prioritized table. Right. So every record in that table shows up. You see, we did not even check if the customer placed an order or not. No, every one qualifies. What's the goal of this? The entire left table is shaded. You see, it means that every row on the left table shows up in the final result set. You see that? Now, so the condition now affects the opposite table. In this case, the orders table. Will this record show up in this? Let me first of all align the column name to make things easy. So I'm going to copy the column layout and just put it right here. So please take note, for a left join, the condition, the join condition is applicable to the opposite table, not the left table. Every row on the left table qualifies. You see, I did not even check anything. No, just copy everything and dump it right here. Right. Now the check is done on this side. We're now looking at the intersection. So is this row going to show up in this left join outcome? These rows on the opposite table will only show up if they have a match. So 1 is 1, yes. customer ID 1, it maps to customer ID 1. So I'm going to highlight this and put it next to customer ID 1. This is an order which was placed by customer ID 1. You see, customer ID 1, customer ID 1. We go to the next. This is customer. Let me just stay on customer ID 1 and exhaust the list. So we go to this. It's the same order, right? Sorry, another order coming from the same customer. Why? This is customer ID 1. I'm going to copy this one and just put it. I have to duplicate this, right? So it tells you that this will occur 2 times. Let me make space for that. Was let me repeat this. So there's an order right here which is coming from that same customer. So I'm going to make space right here. Let me see if I can insert this. Right. So this is going to repeat. And now, in fact, it's repeating the same information. It's the same customer. So I'm going to put it right there. So now we can take this and link it up with that. See that? So it's the same customer who placed this order, same customer ID, same customer ID, same customer. So in fact, we've already outlined the 2 orders that came from that customer. 1, 2. Now let's move to this. Right. So what value is going to go on this side? This is customer ID 2. Let's look for orders that are tied to customer ID 2. We have one, just one, this one right here. So we're going to copy this and put it right here. So this is me doing the matching records. For any row to show up on this side, it must have a corresponding match on this side. This is very important. That's where the inner join concept comes in. This part, you see, this is very important. You see that? So we started off by listing all rows from the left table. Very important. And then now for a row on this table to be listed, it must have a corresponding match. That's a very strict condition. You see that? So if we are looking at this right here, 2, customer ID 2 has just one order. That's it right there. We move to the next one. Customer ID 3, how many orders? Customer ID 3, this is 1, this is 2. So I'm going to make 2 copies of that. This is the first order. It's going to be aligned to this one. So I'm going to put it right here. And just like what we did in the previous scenario, I will just go right here and try to insert. So I'm making room for the next order of that same customer. So since it's the same customer, we repeat their information right here. You see that? And now we can, add this row to that. See that? So I'm doing the sorting as well, because normally it will just do it and then without the order by. So I'm actually doing the order by. That's why you see the customer IDs are, sorted. See, so you can clearly see the 2 orders that came from that customer ID 3, which is this 1 and 2, and these are the 2 orders from that particular customer. Customer ID 4, see, this customer has to show up because it's from the left table, it's the customer's table. Are there any others? We list them out. So on this orders table, there's a customer ID 4 plays this order. So we have to copy this, and it's just one. Customer ID 4 plays only one order. So I'm just going to put it right here. See that? We now move to the next customer, customer ID 5. Customer ID 5 plays one order, this one. So we're just going to take this order information, that row, and align it with this one. That's the match. So you see that at any given moment, the customer ID value on the left table is matching the customer ID value on the right table. See that? This is very important. Right. See that? Now, customer ID 6 Did they place an order? Customer ID 6. They have one order, which is right here. So I'm just going to copy this information and put it next to a row for customer ID 6. You see, it's still matching this and this. Right. Now, customer ID 7, they did not place any order. If you look at the customer ID, for customer ID 7, you don't find it. Now, this is where we put our null. So this is an indication that we have missing order information for that particular customer. So every column coming from the orders table will carry a null, indicating that that particular customer did not place an order. This is very, very important. And these are the things we missed out on the inner join, because the inner join does not focus on this non-matching records. The inner join is all about the intersection. So those nulls are the zone right here. Those who are in the customers table but did not place any order, they are found in this zone. Customers who place an order, they are right here. That's the intersection. And you can see, so that's the same thing for our customer ID 8. They did not place any order. So every column from the opposite table, which is the orders table, will carry a null. And that's it right there. Any question? So this is the outcome of the inner join. This zone right here is what you see in this left join, this intersection. Then these two below, these ones right here, are those that are outside the intersection. Those are customers who did not place any order. So they're outside the intersection. This right here. So please take note that the left and the right joins, they have two zones, inside the intersection and outside the intersection. And any question you can solve with the left join, you can also solve it with the right join. So I can switch the position. I can put my table 2 now to be customers table. Table 1 is orders table. You see, I'm still prioritizing. This is now on the right hand side, and I can do a right join. So the position of your prioritized table dictates if you're doing a left or a right join. Any question that you can solve with the left join, you can also solve with the right join. But then you must be skilled to place the prioritized table on the right spot. Left and right are different. You see that? This is very important. We did not see that scenario for an inner join. If you do table 1 inner join table 2 or table 2 inner join table 1, the intersection is not going to be different. It's the same. Draw 2 circles, one table 1. In fact, let me do that right here. If I just stay on this document, let me get an arrow. I'm just going to draw 2, make them intersect. This is my table 1. This is my T, or let's say this is B, table T and table B. The inner join intersection is right here, this zone. See? If I draw another circle and I reverse the order of the table, this becomes my table B, and this becomes my table T. Guess what? The intersection does not change. It's the same zone. Right? You see? But then it's different now in the case of a left or right join. If you interchange, you're dealing with something different. Right? If you put table 1 on the left hand side, you're dealing with the left join, and this is a zone right there. Right? If you switch the position, you're dealing with something different. This now becomes, so we can switch. Table 2 goes on this side. Table 1 goes on this side. Table 2 comes on this side. Right? And we're now changing the name of the join to a right join. So left or right simply depends on the position of the prioritized table. For an inner join, there's no prioritized table. All the tables are treated equally. We are focusing on the intersection. The prioritized table is a table that has the upper hand in the join. And you can see it from how we solve the equation. The prioritized table, we just copied everything and return it. That was the first thing I did. I went to this zone, copied everything and put it right here. So in the prioritized table, all rows in that table must qualify for the final result. So the join condition now is strictly applied on the opposite table, the non-prioritized table. For this row to show up in the result, it must have a corresponding match. This is it right here. See? Right. And then the rows of the prioritized table which are not found on the opposing table, they get null. These are customers who did not place any order. Questions? Okay, so yesterday let me show you something we did yesterday. We talked about this document, day one. Yes, so week 4, day one. I did was a PDF document. This one right here. Right. So in this one we had table 1 and table 2. We did demonstrate the concept of the inner join. Right. And I want us to do the concept of a left join. In the left join, let's prioritize table 1. So first thing you notice, every row, all the 1, 2, 3 rows of the left table will show up in the result. Right. Which rows in table 2 will show up? They must have a match. You have to take the ID, this ID 20165. Does it have a match right here? Yes, 20165. So this one is going to be mapped to this. Is this one going to show up? 20800. It has no corresponding match on this side. So we're going to drop this row. See that? All right, let's build this scenario. I think we have the database for this. All right. So the first thing I want to do is build these concepts in Excel. Once we're okay with it, then we can then move to SQL Server Management Studio and build the code behind that joint, right? So this database we're gonna use, yes, I think this one. Yes, we're gonna use this database. Right, this is where you're gonna find table 1 and table 2. Select star from table 1. So this is the information you get for table 1, ID all the way to publisher type. And if you go back to this PDF document, this is the content for table 1, ID all the way to publisher type, 3 rows, right? Now for table 2, let's see what we have for table 2. I'm just going to copy this and then change table 1 to table 2. Table 2, this is what we have. The book title all the way to the ID. So we have book title all the way to the ID. And now before you join any two tables together, they must have a mutual column. I see ID on this side, I see ID on this side. Right. So I will do the same. I'm going to copy the outputs of these two tables and take them to Excel, and let's manually build the left join between these two tables. So I'm going to paste the tables and we're going to do that formatting. So this is the table 1. Let's just beautify this, make this bold. This is our table 1. Let's go get table 2. This is table 2 right here. Copy with headers. And I'm just going to put it next to our table 1. So this is table 2. Let's give this. Now for a left join, This is very important. So for a left join, we must make sure we get all the records from the left table. See, there's no question asked. This is just like a reflex. You just copy every row from the left table. So there's no condition being applied to this. This is very important. You see, a left join, table 1 is on the left side. We are copying entire table 1 is going to feature in the result. This is very important. That is something you have to remember. If you look at the Venn diagram representation of these join types, the entire left table is shaded. It's green. Green means that we need all the records from that left table. And that's exactly what I just did right here. All the records from the left table, I've copied them and they feature in the final result. Now, which records of this table will show up on this side? You see, only the corresponding one, only the matching ones. You see, this side is white, and this, so the only thing we're getting from this side is the matching ones. This is very important. I want you to understand this visual right here. Right. So for this row to be added to this result we're trying to build, it must have a correspondence on the prioritized table, that's table 1. And that's why we look at the ID, the mutual column, the value of the ID 20165. Do we have a 20165 right here? 20165, we have it right here. It's already showing up right here. So we're going to copy this. Let me just get the column layout. Let me address that. And then now we can focus our attention on the values. Right. So this right here, 20165, we already have it. Right, is this one. So we're going to put it right here. 20165. You see? 20165, 20165. This is very important. Please take note that the opposing table is white on this side. So the focus is what? Matching values from that opposing table. So for any row to qualify on this side, it must have a correspondence on this side. 20165, that's the ID, it matches this one. That's why we've aligned it right there. All right, we go to the next one. This one right here, the ID value is what? 20800. It has no correspondence. We have to drop it. You see, there's no, we're going to skip this. So we just skip it and we go to the next one. Will this row show up? The ID value says 20034. Do we have a 20034? Yes, we do have a 2034. It's already in the output, this one. So we're going to copy this and place it next to the matching value. You see, that's it. Right. Now the question is, why should we keep this in the result? It's a left table, it's a left join, and this row happens to be on the left table. All rows from the left table must show up in the final result. Right. And so for this to show up, what should we put on this side? Nulls. Because 20233 does not have a corresponding match on this side. So we have to use the null concept, the null placeholder right there. Right. We cannot dismiss this value. That's what an inner join will do. An inner join will give you this result. Only. That's the intersection. Values of this that are also in this intersection. Right. This is very, very important. I really want you guys to sit back home and understand this. Let's see how far we can go with the understanding class. You have to ask questions, right, so that when you go back home to study this, it becomes easy. This is the final result of a left join in which we are prioritizing table 1. We are placing table 1 on the left hand side. This is very, very important. You have to understand, why is this row showing up? It doesn't have a corresponding match. Right? If you're doing an inner join, this will not show up. You have to understand that. Right. So this right here will be the result we'll get for an inner join between table 1 and table 2. And that's what we had from yesterday. This is what we did yesterday. This is a result of an inner join. Right. This will be an inner join outcome. Right. Meanwhile, the one you see above, this one right here, will be a left join. The result for a left join, there's a huge difference, right? And the steps to follow is very important. For a left join, you begin by copying every row from the left table, and then you go now to the right hand side, to the right table. Which rows on the right table will be added to that result? Only those that have a corresponding match on the prioritized table. You see, you have to understand why we dropped this out. Why was this dropped out? Because the ID is 20034. It doesn't have any correspondence on this side. Right. Again, questions on this? Okay, I guess you're all waiting to see the coding aspect of that. Yeah, let's go ahead and do the coding aspect. It's going to be the same thing we did yesterday. Instead of inner, we're just going to put left join. And that's it. So let's look at this one right here. All right, so let's do a join between the customers table and the orders table. Right. In fact, for me to stay on point on this, let me get to this. Document. I just want us to have something in front of us while working on this. All right, so this is a pre-prepared stuff. Can you just open this document? All right, I want us to have the same stuff. Anyway, before we open that, you know what? Let's just go ahead and build the. Let's go ahead and build this outcome. Let's build this together. All right, let's build this together. Customers table, orders table. For this, use the customer insights database. So you see the database I'm connected to is customer insights. This is the customers table. This is the orders table. And if you execute both of them, you get two output windows. You can clearly see that customer ID is the mutual column, right? So for you to join two tables, they must have a common column, a column that is common to both tables, right? So in this case, it's a customer ID, right? So let's build a left join together. So left join, we are prioritizing the customers table. So what does that mean? We want to return all customers. So we are returning all customers, whether or not they place an order. So the goal right here is to return all customers. So let me state our goal, return all customers, right? So return all customers. At this point, you know you're not dealing with an inner join anymore, right? Because an inner join will only return values for which there's a match. So that when it's telling you to return all values of a particular table, you're no longer in the framework of an inner join. This is very important. Right, let me go back to is that right here. See, an inner join is actually simple and direct. Whenever you're interested in the intersection between two tables, you see, the goal is simple and straight to the point. If you're asked to return all values of a given table, then you're either in the framework of a left or a right join, and the developer, makes the choice. Developer A can choose to do a left join, B can choose to do a right join. They will all have the same result, as long as they respect the position of the prioritized table. If you're doing a left join, your prioritized table must be placed on the left hand side. If you're doing a right join, the prioritized table must be switched, must be placed on the right hand side. All right, this is very important. Let's demonstrate the syntax in this process. So the goal is to get all customers. All right, this is very important. So our goal here is simple: return all customers. So we're going to be joining the customers table and the orders table, and the manager wants to make sure that every single customer shows up. So that is already a clue that customers table is the table that we're going to prioritize, right? So once you know the prioritized table, if you choose to place that table on the left hand side, you're condemned to do a left join. You see, and if you choose to place that prioritized table on the right hand side, you're condemned, or you must do a right join. Right, this is very important. So what is the left table? Is a table that is your table one, the table immediately after the from clause. The first table you call as a left table. If this is difficult for you to remember, right, I'm just going to put these two together. I want to declare left join right here, put them on the same line. Now, when you have this written out, stretch both hands to the screen. If you stretch both hands to the screen, your left hand will be on the customers table and your right hand will be on the orders table. Right, I know at the beginning, students always get confused. Which table is the left table, which table is the right table? It's easy. Put the two on the same line like this. See, select start from, this is table 1, left join table 2. Stretch your hands on the screen. Your left hand will be on the side of the customers table and your right hand will be on the side of the orders table. So if the table you're prioritizing is already on the left hand side, you must do what? A left join. You see, that's how I'm doing a left join. If I switch this to right join, then I have distorted this. I am showing all orders. So orders table is now the prioritized table because this is a right join and orders table is on the right hand side. So you cannot place customers table on the left hand side and your target is to prioritize the customers table to return all customers. This is wrong. This must be a left join. See that? Now you can go ahead and state the on. By the on clause carries a mutual column. See, things I always want to make it a habit to give aliases: C for customers and O for others. It's going to be easy. Now I can just put my C, which is for customers table. When I put a dot, I see the list of all columns on the customers table. Customer ID equal to, instead of typing dbo.others, I just know the reference was O. See that? And if I just put my O dot, and I'll see all the columns from the others table, customer ID right here. Now see what happens when I execute. This is a left join. See those two customers who did not place any order, and on the orders table, you see every single column points to null. That's the same thing we did in Excel. I think it was this one right here. Right here, you see those customer ID 7 and customer ID 8. These are the two customers who did not place any order. And how can you confirm that? Just go to the orders table and look at customer ID. You don't see any 7 or 8. See? And so what do we get? We get nulls on that side. See that? No order is tied to these two customers. So every column from the orders table gets a null. Right? And this is it right here. I want to stop right here and wait for you guys to code this. If there are any questions, you can ask. Yesterday we did an inner join. If I just switch this to inner join, right, or I just remove the word inner, it's just to do an inner join. If I run this, you have to understand why those 7 and 8 will be kicked out. This is just strictly intersection. Only customers who place an order. See? So we've dropped those customer ID 7 and 8 would not place any order. That's why you don't see them on the list. Right? If I go back and switch, hey, I want to do a left join. So I'm prioritizing the left table, which is what the customers table. I want to get all customers, whether or not they place an order. This is it. This is your intersection right here. And this is the zone, two individuals who are outside the intersection. So you have to understand that left and right join, there are two zones. An inner join has only one zone, the intersection. The left and the right join, they have two zones. The zone in the intersection and the zone outside the intersection. And you must be able to look at the result and classify the zones. These are those that are inside the intersection. Customers who have placed an order. You see the customer information and you see the order information. These are customers who have not placed an order. You see their customer information true, but you don't see any information about their orders. Null. These individuals are outside the intersection. They are right here. Right, this is very important. I want to take a little break right here so that I can give you a chance to code this, play around with it, and if there are any questions, let's address it. Especially for those who missed the class yesterday. All right, let's catch up on this. Okay, so I'm going to pause a little bit and allow you guys to write the code for the left join process between the customers table and the others table. Okay, any question? Okay, I would like us to, yeah, question, yeah.
So I tried executing all of what you just did right now and try to compare the tables.
Right.
But when I look at it, that is what is left joined. But when I look at the table, it just seems like two tables that has been joined together. I don't know if that was the concept because, and also it makes sure that the first table that was the first table that was customer came on
Right.
the left side and joined it with the other table. Was it meant to be like that for a left join, or was is it like is the concept that the first table on from the left join, which is customers as it says from the question, is it meant to be on the left while the other one just come? I don't see them merging. I just see like when you take two separate tables and just join it together, but with the customer table on the left and the other one on the right. Is that the concept of left join?
Yes. So let me project the result so you can see. So merging, I use a word that is very interesting, the merging of tables, right? So the tables are not going to really merge. They will be kept separate. In fact, let me see if I can show you the split point. This is it right here. So on the left hand side is the customers table, and then on the right hand side is the orders table, right? Let me see if I can do this. So right here, this is the customers table, right? And then on the other side, we have the orders table, this one. Now, so the tables are placed side by side. You see? Now, how does the system knows that this row right here from the orders table should be placed next to this row from the customers table? That answer is based on the mutual column, right? So this is very important. You ask a question that is very critical. Let me go and remove this, right? And let me show you what drives this process. It's the on clause. You see what we've stated right here on the on clause. This. So anytime the customer ID from the customers table equals the customer ID from the orders table, then show that row, right? So after showing all the rows from the left table, which is the customers table, now what rows will show up from the orders table? The rows where there is a match. So notice each time you see customer ID 1, this is from the customers table. If you stay on this row, you're going to see the same customer ID 1 on this side. This is the behavior captured right here on the on clause. Right. I know these two are different, right? But then if you check every other one above, this is the concept of an inner join, this part right here. You're getting only the matching values. So each time you see a customer ID 1 right here, if you go to the orders table, customer ID 1 is the, that's why these two are placed on the same row. Right. So the first concept is that for joins, the tables are placed side by side. Right. And then how do we know what row of the left table will be aligned to what row on the right table? Is based on the mutual column. So each time the IDs correspond, we place them next to each other. See that? You can clearly see that the tables are placed next to each other, side by side. Right. And then now we focus on mapping the rows of the table. Right. Why was this row from the orders table, this row right here, why was it mapped to this row on the other side? This row came from the customers table. Why was it mapped to this row from the orders table? The mapping is done based on the condition you see right here. Customer ID. Customer ID 1, customer ID 1. So this customer right here is responsible or placed, is the individual who places this order. See? The reason why we put customer ID on the orders table is to track down what customer placed what order. Imagine that there's no customer ID. You'll be looking at orders and you don't know what customer placed the order. Right. So we are making sure that we don't align a different customer to the wrong, sorry, we don't map the wrong customer to the wrong order. Right. And this is the goal right here. Customer ID 1, they are the one who placed this order. Why? Because customer ID 1 is showing up right here. Second, this same order was placed by customer ID 1. See that? Right. So the concept of merging, it will seem like the tables will be fused together. Right. That's not what is going to happen. We'll kind of talk about union where the tables are stacked to each other, and you're going to see the result will be different. Probably that's what you're thinking about. But for join, the tables are placed next to each other, side by side. You can trace all the columns that came in from the customers table. That's why we begin by exploring the tables. If you look at, if I run this, I get 1, 2, 3, 4, 5 columns from the customers table. Let's explore the orders table. I get 1, 2, 3, 4, 5. So even without executing the join between these two tables, I will get 10 columns. 5 from each of them, 5 from the customers table and 5 from the others table. You see that? Right, so it just tells you that, hey, for joins, it's a side-by-side process. And this mapping also in the document helps you. Left join, follow the mapping. The black dotted line, it moves from customer ID 1. We map it to this. See, so this row from the customers table will be placed on the same line as this row from the others table. That's the line you get right here. Second, that same customer also placed another order. So follow the dark dotted line, it leads to this. Now this will show up again and it will map to this line right here, this row. Now if you go to customer ID 2, follow the red line. The red line maps to this customer ID. You see that? So customer ID 2, this customer information will be mapped to this row. And that's why if you go to this, you see right there. You keep mapping right until you exhaust the complete table. But since we're dealing with a left join, those customers who did not place any order, they still show up on the result. Why? Because it's a left join. And in the left join, we are targeting all rows from the left table, no question asked. Right? No row gets kicked out when you're doing a left join from the left table. Right? Some other person will look at this question. Okay, we want to return all customers and see what they do. Instead of beginning with customers, they put orders. Right? Let's run this process again. Right? What will happen if I start the process by looking at the orders table as O, and then I now do an inner join. Sorry, not inner join. I now do let's stick to the left join. And this is one very powerful thing that you have to understand before we close the session for today. Customers. As C. Now I specify the on clause, which is simply the mutual column from O. Table O, that's the orders table. We have what? Customer ID. Now I put this country ID, sorry, customer ID. From C, what do we have? Customer ID. See that? This right here is not going to be the same as this. They all seem to be doing a left join. Let me just put this to the next line so that you understand. They're all doing a left join. See, they all say left join, right? But you have to remember that the order of the table matters for a left join. Let me do this same process right here for an inner join. Let me just put it on a new query window. In an inner join, if you switch the table, it doesn't matter. So in this one, I'm beginning with customers. I do inner join orders. Just stay with me on this concept. Let me demonstrate something. I begin with the customers table. I do inner join orders. On this one, I begin with the orders table. So I've switched the tables. I'm now beginning with orders. I do inner join customers, you see. So in this join, I did begin with customers followed by orders. Both are doing an inner join. In this one, I did begin with orders followed by customer. But then if you look at the number of records returned is going to be the same. Inner join is going to be the same. The only difference you see is the position of the tables in the result. Since you began with customers right here, this first output begins by labeling or laying out the columns from the customers table. That's the only difference. But in terms of the business logic, the results they return is the same. 16 rows. Sorry, not 16 rows. Let me run this one. Let me run them separately so you see. So 8 rows for this. Why do we begin seeing the customers information first? Because we started off with the customers table. So this is customer information, right? By the time you kick out the asterisk, you can now control how the columns will appear. So it's not a big deal. See that? Right. So this is just to highlight the fact that if you do table 1 inner join table 2, or table 2 inner join table 1, the results are the same. You have to understand why, because the intersection does not change. Table 1 inner join table 2 is the same as table 2 inner join table 1. The intersection does not change, right? But that's not true for a left or a right join. And that's the point I want to make, right here. Let's go back to this. So when you're dealing with the left join, you have to focus on the order of the table. Which table should come first, followed by what? If the question says return all customers, like what we have here as a goal, then your prioritized table, if you place it on the left side, then you must do a left join. So this is valid. The table I want to prioritize based on the business requirement is customers, and I'm doing a left join. Why left join? Because customers is on the left hand side. This is justified. Execute. I get that. See, 10 rows. See, this is not justified for this business requirement. The goal is what? Return all customers. This is a left join. What table is being prioritized in this join? Is the orders table. Orders table is on the left hand side. So we will be returning all the orders. See, that's a different prioritization. You see what we get? Different result. This is very, very important. So what is the correct way if you want to use a left join still? You must switch the position of the tables. Right. So if you're beginning with the orders table, right, and you have your customers table right here, this should be right join. So this is the right thing to do. For this and this to get the same result, you must focus on the position of the tables. So the question always begins with, what is my table? What is the prioritized table? What table am I prioritizing? That's where everything begins. If you choose to put your prioritized table on the left hand side, you must do a left join. It's not negotiable. If you choose to put your prioritized table on the right hand side, you must do a right join. It's not negotiable. And that's how these two will end up giving the same result. Right, so a left join or a right join will end up giving the same result, provided you respect the order of the table, the positions of the table. There's a reason why this is called left, and there's a reason why this is called right. The two are the same, right? They can achieve the same result, but you must know how to position the prioritized table, right? Don't interchange them. Left and right, it depends on the position of the prioritized table. You see that? So this is a left join. What table is being prioritized? The left table, customers. This is a right join. What table is being prioritized? The table on the right hand side, customers. So these two joins are identical, they're the same, because they are prioritizing the same table. Right? This is very important. Any attempt to interchange them, you're gonna get an error. Or let's do more examples on this so that we can understand this. In fact, what I can do, let's open the SQL script for today. So we're looking at week 4, day 2, outer joins. Let's go ahead and open that script in Management Studio. So click on the icon to open file and just navigate. This is week 4. Let's go to day 2, and this is the file we want to open. Right. So a lot of things I've explained, you find them right here. And this is the W3 schools. I will go to this website. Let's just explain this concept. So outer joins, we have left, right, and full. Left and right can be used to solve the same question, right? But then you have to recognize what table is being prioritized, and you must make sure you put them on the correct side. So if the priority table must be on the left side for you to do a left join. For the right join, the priority table must be on the right side for you to do a right join, right? And then we have the full join. We're going to come to that later on. So left join, these are some key points you have to remember about the left join. It retrieves all records from the left table together with the matching records from the right table. This is what we saw in Excel when we did that demonstration. So we are retrieving all the records from the left table. That's why we started off by copying everything from the left table, put it right here. All right, so that's the first part. All records from the left table, now together with what? The matching records from the right table. And that's how you build that intersection. So the matching ones from this side. And there's one extension right here. The order of the tables matter. This is very important. The order of an inner join does not matter. The order of the tables when doing an inner join does not matter. You can do table 1 inner join table 2. It will be the same as table 2 inner join table 1. But if you try to switch that for left and right joins, you're gonna get yourself confused. Right. So for a left join, the table on the left hand side is the prioritized table. This table right here. So since you're doing a left join, this is the prioritized table. Right. So the priority table should be placed on the left, table 1, if you're doing a left join. So when you read the question carefully, it will give you that clue. For example, see this question right here: retrieve all customers and their orders. The fact that we've been told all customers and their orders. So the goal is what? All customers. So the customers table is the table that should be prioritized. Now the choice is yours. If you want to do a left join or a right join, it's still valid. But know that if you're doing a left join, that customers table, which is a prioritized table, must be placed on the left hand side. If you choose to do a right join, customers table must be on the right hand side. So this left or right is just the choice of the data analyst. But then you have to understand what you're doing. So the goal right here is to retrieve all customers. This is the database we're using. We are retrieving all customers. Since I'm doing a left join, customers is on the left hand side. We'll get all the customers. This is very important. We're getting all the customers. This can only be delivered through a left join. Why? Because the customers is on the left hand side. You see that? So this is the query right here, which will give that. We have all the customers listed. These are all the customers. It's just like you copied everything from the customers table and you put right here, right? Everything listed. Of course, some customers can have more than one order. You see, right? I'm gonna skip this full join concept. I think anyway, it's easy. So full joins are easy. We are just returning all the records across the two tables, and then while keeping the mapping, right? If it matches, we keep it. If it doesn't match, we put a null on the opposite side. So if I switch this to full join, you're gonna see that there will be an increase. You see, it's a full join. So a full join, you see the entire left and right tables are green together with intersection. So we're getting everything across the two tables. For a left join, we are getting everything from the left table, including the matching values. For a right join, we are getting everything from the right table, including the matching values. For a full join, we are getting everything across both tables. Okay, let me see. So list of all students irrespective of projects being assigned to them. This is a presentation database. We had this database yesterday. It just shows you a list of students and the projects they are assigned to, right? So we are returning all the students. Guess what? The student table is the table we are prioritizing. So if you use a left join, it means that what you have to put the student table on the left hand side. This is a left join. We are prioritizing the student table. We are placing it on the left hand side. So we're going to get all the students, whether or not they have a project assigned to them. And so this is a picture we are looking at. This is table 1 is a student table. Table 2 is a project table. A list of all students, whether or not they have a project. This intersection is a list of students who have a project. Students without projects, they're going to be on this side. And when you execute that join, you will see that two zones, right here. When you see the student ID and the name of a student, then on the project, you see no project, null. That's a student who has no project. Right, these are students that are outside the intersection. See, So whenever you see null, it's not just for project title, every column from the opposite table. So the opposite table is what? The non-prioritized table is a project table. So if I want to get all columns from that table, I can just put p dot asterisk. This is an easy way. See? So p says what? We are looking at the project table, that's the alias. And then dot asterisk simply means give me all the columns from that table. Right? And if I run it, you're going to see that you get nulls. This is the project table. It has project ID, project title, and student ID. They're all nulls. See? It means that this student right here, Priska, was not assigned to any project. Collins also was not assigned to any project. So, but why are we getting these students that were not assigned to any project? Because of the business requirement. The business requirement stated that we should list out all students. See, list of all students, irrespective of projects being assigned to them. If we're told to only show students with projects, then that will be easy. That's an inner join. See, we are now in this zone. So please, the goal is for you to read a requirement and then try to come up with the Venn diagram that best describes it, and then you can know now what join to go for. You see that? So this is not a scenario where we are asking ourselves to only show students who are assigned to projects. That will be an inner join. And so in this case, you will not see those nulls, right? So every student you will see the title of the project. See, I can do a split right here. On the left-hand side, you have the student table, on the right-hand side, project. So every student listed on this list has a project. That's an inner join. So you're looking at this scenario. But if I change this to a left join, I will get all students. And remember that a student can have or not have a project. And some students have multiple projects. So if I switch this to left, it gives me a good picture while prioritizing the student table. So I get to see all the students. Those that have projects, you see their projects listed. Those that have no project, you see nulls throughout any column from the project table. Right? And you can classify these are those that have projects in the intersection. Those without projects are going to be right here. See that? Right. This is very, very, very important. Now let's do some further analytics. Let's show all students and the number of projects assigned to each. In fact, you know what? Let me do this all over so that we can see. Let's try to make sense of this. Show all students and the number of projects assigned to each. So it's a counting process. So we're going to show the name of a student, for example, the first and last name, and then we count the number of projects assigned to them. So this is going to be a counting process. And the goal is to show all the students. So some students that have no projects, you're going to see a count of 0. You see that? So this is going to be a counting process. Right. So first, let me show you something right here. There are 2 tables involved. Select star from. If I stay only on the student table, I will not be able to solve this question. Right? If I stay only on the student table, I will not be able to solve this question. You see that? Because on the student table, I have no clue if the student has a project or not. It's just student information. To know if a student has a project and how many projects, you need that information from the project table. So that tells you already, for you to solve this simple question right here, you must join the student table and the project table. That's how these things begin. Right? You have to understand that we are now moving to a higher dimension, where when you read a question, you have to understand if this question requires more than one table. Right? This is very important. If you stay on the student table alone, you will not be able to solve this question. Right? How will you count the students who are assigned to projects? There's no information right here for you to do that. You need to do that on the project table. And if the manager tells you, show me the first and the last name of each student and the number of projects they're working on. First and last name will be gotten from this table, true. But then count of the projects, what column will you use if you stay on this table? See that? So to better solve this question, we will need the 2 tables, right? let me again reinforce this knowledge. So I want to get the first and the last name of each student, which of course we'll get it from the student table. But then I want to count the number of projects assigned to each student. That counting will be done on what? You can use something like the project ID. Count the number of projects assigned to each student. You can count on the project ID. See? So it means that these two tables need to be brought together. You have to join them in order to solve this question. Right? And that will be the first step, right? So you see, I've explored the two tables. Let's now go back and check the mutual column. I think I saw something like student ID, student ID, student ID. This is very important investigation. And now know what column I will use on the on clause. So since we want to show all students, now you go back to the question. You want to show all students. If you decide to begin with the student table, then you must do a left join. If you disclose that your prioritized tables on the left hand side, this is a left join scenario. See, this is very important. You're going back all students. Oh, we need to prioritize the student table. We need to show every student in the student table. So if you place student table on the left hand side, then this will be a left join. See? So let me just call this S for student. I like using alias. It helps to, so this is going to be a left join. And then next, I can bring in that schema project table. And let's just alias this as P. Now the on clause. We've seen that student ID is a mutual column. So from the student table, which is now S, see, instead of typing all of this long stuff, we just call it S. You can use any code. It's up to you to decide. Right. So if I just go ahead and put S dot that student ID equal to from the P side, the project table P dot student ID. This is a left join. What does a left join do? It prioritizes the table on the left hand side. What does it mean to prioritize a table? It means to show all the records from that table, and that's what this question is all about. Show all students. So if I run this, I've been able to join those two tables together. Right. And then after joining the two tables together, what are the columns we need? Show all students. So student information now can be a combination of your first name and last name. Right. Let's combine the first name of each student and the last name. Let's put a space in between. I think you're familiar with this process. All right, this is the student's full name. So show me a student's first and last name, and then tell me how many projects they are working on. This is counting exercise, so you have to count the number of projects by doing what? A count on something like the project ID. See? Excellent. Count the number of projects a student is working on. You count on the project ID, and this will be our number of projects. If I stop right here and execute this, please don't get confused on this. This is an error, right? It still goes back to that same thing. This column has been aggregated. These two columns have not been aggregated. So we have an aggregated column that is mixed with a non-aggregated column. What do? This everything right here goes to the group by. Right. So what are we doing? We are putting all students in each student in a group, and then we are counting the number of projects assigned to that student. So the grouping has to be done at the student level. That's through the what? First and last name. So I'm just going to copy that same structure, right? And I do group by this. Let me copy that again. Control C, Control V. And now see what we get. This will show you each student. And we're getting all the students. You can confirm this information. There are 41 students. Go back right here. Run this. 41 students. See, we are showing all the 41 students. And we are counting the number of projects they are assigned to. Of course, since we are doing a left join, that's why you're seeing students with no project. If you switch this to an inner join, all those students with zero counts of project, they'll be kicked out, because inner join between the student table and the project table, you're looking at what the intersection. What is the intersection? Always interpret the intersection as per the business requirement. If this is the student table and this is the project table, can you describe the intersection from a business perspective? These are the students who are assigned to projects. So if you don't have a project, you don't feature. Right. So if I switch that to an inner join, all these zero counts will go away because zero means that student has no project. It should not be showing up on that list. You see, now we are down to 20 students. So out of the 41 students, only 20 have projects. See, but then if you change this to a left join, those students without projects will start showing up. See, you have to understand the zones. Venn diagram will help you to visualize this process. All the interviews I've been to, when I'm asked a join question, I always have my pen and paper and I draw a Venn diagram to represent and I explain. It helps you to, to explain the concept. This is very, very important. You see that? So you have to understand that changing from this left to an inner, the number of rows will be impacted. So let's go back to this. We now start seeing students with no project, zero counts. The student has 4 projects, you see. The student has 1 project. The zeros here are showing because we did a left join. And the goal was to show all students, right? So this is it. Everything we've studied up until this moment still applies. The join is only impacting the from clause. Every other analytics is applicable. Your where clause can be added to this. Your group by can be added. Your having clause can be added. Your order by. We've just simply expanded the scope of the table. And that's what we call multi-table queries. You see, we're querying 2 tables at the same time. So first of all, figure out a way to join them. You saw the steps I did. I first of all ignored this. Your first priority should be to join the tables before you start doing any other adjustments. Don't try to target everything at the same time. No, first of all, join the table, make sure it's running accurately. And then now you go in there and perform the analytics as needed. I need to see the first name and the last name fused together. I need to see this, right? So this gives you 2 columns without any name. And now you can go back and make it descriptive. This is what full name. It's a student full name, right? And what column is this? This is a number of projects, right? Number of projects each student is working on, right? Let me ignore the space. I'm just going to type number of projects, right? So yes, we have those 2 columns. This is it. Please, you have to understand why this question cannot be solved using the student table alone. You get the first and the last name true. How will you count the number of projects assigned to a student? There's no column on the student table you can use to do that count. See that? If I go to the project table, I want to solve this question using only the project table. Yes, I will count the number of projects.
No, let me continue.
Oh, is that the question?
Eh,
Yeah,
all right.
that has a question.
Have you posted? Okay, so I was asking about the I don't know what they call it. This red is it what they call it?
Oh, the
The
red.
red, yes, because since we started this, I noticed whenever we put the red open and close, we always put a word inside. But now
Oh,
you're
okay.
doing it. Yes,
Now,
that
yes.
place you've highlighted. Yes.
Right. Yeah.
Why is it empty now?
Okay. Yeah, that's a very good question. So it depends on. I just want to combine first and last name. When you write somebody's first and last name, there's always a space in between. You see that? In fact,
Okay.
let me go back to without this. So you understand the plus sign, right? We want to combine the 2
Yeah.
columns. If I put a
Yeah.
comma, we're separating them. If I put a plus, we are combining them to 1. So this is where the problem starts. And let me just run this part right here. I have to, anything you do on this side, you also have to make sure you do it on this side. If not, you distort the other. So let me run this so that you see. If you present this to your manager, they will not be happy. You see, we've been able to combine first and last name true. but they are fused together. You see, there's no space. It looks like it's one name. You see, so this environment right here is what we call the verbatim environment. Anytime you bring this environment, you can type anything in it. But then what we need is just a space. We don't need any other thing, but it's only a space. That's why we put space right here. And it is this space that will show up between first and last name. See that? So that's the same thing I'm gonna do right here. This space, this, and then you add. So this will take the first name, join it, plus means join it with the space, and then take that space and join it with the last name. If you want to put a space and you just do this, it doesn't work like that. Right? It must be in a string environment. And in that string environment, you can type anything you want to put inside. So for this particular requirement, we just need a space. Some other person will say, hey, give me a hyphen. First name, or a slash, first name slash. So what separates your first name from your last name is a slash. Yes, this will show up. If I run it, you're going to see showing up. See the first name slash last name. But then normally when you type first and last name combined, you always go for a space. You see that space, right? So it just depends on the business requirement. That's a space right there. So yes, that space is due to this symbol right here. And if you make this space bigger, it will also show bigger, right? But of course, spaces are in typing, just tap one tab right there. Right, that's a good question. So this is to introduce a space between the first and the last name. And so this is a structure right here. We preserve it and we use the same in the group by. Right? You can get an error if you use a different structure on this side compared to what you've put in the group by.
Then does the gaps between the spaces, does it matter? Can you just give one?
Oh yeah, that's a
You
good one.
must give two.
Yeah,
Yeah.
let me increase it. Yeah, it's gonna reflect. Why? Because this is a verbatim environment. Verbatim means whatever you type is what you see. If I just go in this, I type, you see that it will show. It will
Yeah.
print out exactly the same. If I go right here and do this, it will, yeah. So that's a verbatim environment. It will print out exactly the same. So if you do like, instead of doing one space, you do multiple. Let me do that. So if I go right here, this is one space, two,
Yeah.
three, for example. So I've done three. Let me do the same on this side. So 1, 2, 3. You notice that it's going to show there's a white space between first and last name. See that the space is bigger, and I can add more. That was 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 10. You see that anything I do on this side, I try to do it in the group by structure. Right. Let me make sure. Right. And if I run this, it's going to show up. That's why we say it's a verbatim environment.
Oh yeah.
10
Okay.
spaces right here. Yeah, that's a good question. So just remember, if you want to print out anything that is not from a column, you can just remember this environment and just type it inside. If I want to put first name dot last name, I just put a dot right here. First name dot last name, I put a dot. It's going to show up in the result. Run this and you see it's going to show up. See first name dot last name. Right. If you want to put this symbol, first name or last name, right, it's going to show up. That's verbatim environment. Anything you type in that string environment, the system will preserve it. It's not going to distort it. Right. Okay, that's a good one. So let's go back to the space. We want to get a space between first and last name. And this is it. Okay, what do we have right here? Now let's look at this question and then see how we can solve it. Let's write a query in SQL to display all departments, including those which do not have any employees. So if you go to this Yeah, there are two tables right there that we need. We need the department table and we need the employees table, right? So there must be a join between the employees table and the department table. But then in this question, what are we prioritizing? Is it employees table or department table? If you can go back to the question, all departments. So we are prioritizing the department table. So when joining the department table to the employees table, you have to prioritize the department table. Right. So the choice is yours. You can choose to do a left join or a right join. But you must remember that you have to place the prioritized table on the correct side, either left or right, depending on what join type you're going for. Right. So we need to combine these two. We cannot just show this. Right. We don't know if this department has employees or not. To actually know if a department has employee, you have to join it to the employees table. So this again, this is not a question that you're going to solve by sticking to one table. If I just run this, oops, no. If I just execute, stay on the departments table, I just run departments table here. See, there are 27 departments. We don't know if these departments all have employees. Right. So for you to know if a department has or has no employees, you have to join into the employees table. And that's the reason why we're doing this join. Now, why did we go for a left join? Because the table we want to prioritize is on the left hand side, which is what department. So we're going for a left join. If I execute this, see what we get. If I stop right here and ask you this question, can somebody tell me one interesting thing about benefits department? From this result, what do you know about benefits department? Construction department, contracting department, control and credit. What does all these departments have in common? Corporate tax department. What do they have in common? They have no employees. See that? If you join the department table, table 1, to the employees table, table 2, through a left join, the intersection will show you only the departments that have employees. In this case, you're dealing with this one. So if I go to this join and I switch it, this is what I want you to do when you're studying. Switch this to inner and see how the result will change. The inner join means that what we are only showing departments that have employees. Only departments that have employees, you see. You don't see those nulls we were seeing before, where you see a null on the entire table. These nulls are allowed. This is just a null in a single column, right? But it doesn't mean you see a null across every other column of that table. See? Right. So if I go back and put the left join, I will be showing two zones. Always remember this. Those in the intersection, what does that mean? The departments that have employees in the intersection. And then those outside the intersection, what does that mean? The departments without any employee. And if you execute this left join, prioritizing department table, you see the results. See, this is example of departments that have no employee. You see every column from the employee table is showing up null. So benefits department, construction, they all have no employee. Also the government sales department, no employee. And in this one, IT help desk, IT support, manufacturing, no employees. See, all null. And also this one, operations, NOC, payroll. Oh, payroll, that's not good. The public relations, the public relation actually has employees. You see. All right, so you have to understand the impact when you switch to an inner join. Always the Venn diagram will give you the zone of interest and you can interpret it from that. All right. Some other person will solve this question using a right join. If you want to use a right join, you switch this to right, you're out of context. You must change the position of the table. This now has to go to this side, and then this has to go to this side. This is a right join. What are you prioritizing? The table on the right hand side, department. Excellent. This is good. Right. So it's not just changing from left to right that matters. It's also respecting the position of the table, the prioritized table. So this is very important. So it just goes back to highlight the concept. Questions you can solve using a left join, you can also solve those using a right join, but you must respect the position of the table. Left join, the prioritized table must be on the left hand side. This is a left join, we are prioritizing departments. This is correct. We are good. If I switch this to right join, and if you ask yourself the question, are we prioritizing the table on the right? In this question, table on the right is employees. Are we prioritizing employees? The answer is no. We're asked to prioritize department. Why? Because we're told to return all departments. The prioritized table is a table from which you're getting all the records. Right? It's a very simple stuff, you see. And it's the same counting process. Count the number of employees in each department. Again, this will be a question where you have to join the departments table to the employees table. What do we need from the department? We need the name of the department. We have a department name. So show me each department and tell me how many employees are in that department. And how do you count employees? You don't use any column from department. To count employees, you need to go to the employees table and count them based on what employee ID. So putting those two concepts together, we need to join these two tables. That's where the analytics begin, knowing the materials we need. You see that? So this is a simple question right here, but you have to understand that it involves joining two tables. Right? Why are we going for a left join? We also want to include on the list those departments that have no employees. But we are targeting all the departments. So we are showing each department and we are counting the number of employees. You see, number of employees. You see, our group by carries this, group by that. The mutual column is what department ID, department ID. And if you execute this, you're going to see some departments have zero. You see, we saw this previously, benefits department, construction, 0 employees. If you don't want to see the zeros, if your manager tells you, hey, just only show, keep it simple, let's just show only those departments that have employees. That's the description of an inner join. You just go right here and switch this to what? Inner. Execute. See? It's much more beautiful right now. You can clearly see that there are 11 departments with employees. If you go to the department table, how many departments does this company have? This company has 27 departments. Only 11 departments have employees. That's true. And see, inner join. So all of these, they have their role to play. But the question right here was to show all departments. Show all departments, including those with no employees. You cannot do an inner join in this scenario. It must be a left or a right join. Why am I using a left join? Because the departments table is on the left hand side. And that's the table we are prioritizing, all departments. You see that? So this is very important. The Venn diagrams will help you always try to sketch the scenario and then know what to do from there. Right? Any questions so far? Or maybe we'll take a break. Anyway, you know what? Before we take a break, let me ask you some multiple choice questions. Right? On W3 schools, W3 schools. Yeah, this question you're just gonna fill in the blanks. Let's go to those left joins. Joins inner left right here, and I'll take you to the bottom. Everything we've explained is right here. See that definition? Always remember to be able to define it. The left join keyword returns all records from the left table. See, this word is very important. All records from the left table and the matching records from the right table. That's how you get the intersection thrown into that. All records from the left table together with the matching. See, so there are two zones, and that's why the entire left table is highlighted green to show that we are targeting all the records from that table. See, the same thing for a right join. All records from the right table, including the matching ones on the opposite table. Right. I wanted us to talk about this exercises. What are those exercises? Okay, I'm gonna skip this ones as simple. Let's go to the joins one. Okay, yeah, this is an exercise on the left join. Okay, so insert the missing parts in the join clause to join the two tables. We have the orders table and the customers table. Using customer ID, they've told you the mutual column to use in both tables as the relationship between tables. So they started off with select star from, specify the first table, orders table. They do a left join, specify the second table, customers table. Can somebody help us to fill the missing parts? What is missing on this side? So we're creating a left join between the orders table and customers table. Select star from orders, left join, customers. What's missing right here?
I guess we're missing the on clause.
Excellent. That's a good start. We're missing the on clause.
Then from there on, we have to say to specify the the column or the column we're using to the relationship column between the both. So
Yeah,
in this case, it's going to be on customers dot customer ID. No, on orders, since orders is more or less the orders dot.
that's a good point. But in this case, it doesn't, since it's
It doesn't
equality.
matter.
Yeah, so you can
Okay.
put this dot this. Right, and then you go to this side. What is missing on this side?
Equals to customers dot customer ID.
This is very important, guys. This dot customers dot customer ID. If you want to practice this, you're gonna use the Northwind database. So W3 Schools runs on Northwind. If I open a new query window, and that question is, this is actually what we're doing. This is it right here. Right. So if I knock this into an asterisk, in fact, let me just put it on a new stuff. Let's do it together. We want to, so we are using Northwind, use Northwind, and we are joining customers table to the orders table. Right. Let's first of all explore the two tables. We're going to be joining the orders table with the customers table. Right. So this is dbo dot orders. Why is it not showing up? Is it orders? Yes, orders. That's the first table. Let me pull up the second table. It's going to be customers. Customers. Right. Now let's explore these two tables and then discover the mutual column. It was specified in the question, but let's just do it. Customer ID, and then you're gonna see each time you see a customers table and orders table, they always put the customer's ID on the orders table so that we get to know the customer who placed the order. That's how you create the relationship between the two tables. Right. So customer ID is right here on the customer side, and then there's customer ID right here. Sorry, customer ID on the other side and customer ID on the customers on the customer side. Yeah. So to join these two tables, this is what was provided. So this part was provided. They did provide select star from. They specified the first table, which is the orders table. Since it's DBO, we can drop the DBO reference. Right. That's the default schema. Right. So they did provide this part, select star from orders. They did also provide this part. They're doing a left join. Customers, they did also provide this part. And like what Alex said, we were missing the on clause, this part. And we're told to use custom ID. Explore that custom ID is necessary. Right. So this is it. You're gonna do orders dot customer ID equal, from the customers table, we are putting this customer ID. I need to ask a question. Why is the table reference needed on the on clause? What will happen if I just go and just dismiss this? Right, since we've investigated the mutual column is custom ID, we just put custom ID equal custom ID. So custom ID equal custom ID. Right, why is the system giving me an error? And this is an error that everyone should know, ambiguous. When I put my cursor right here, can somebody explain why we're getting an error if we do this? This is a concept from yesterday.
It's because since custom ID is in both tables, so the system doesn't know which of the tables we are referring to, kind of.
Excellent. Yeah, that's a source of confusion. So if we just put custom ID right here, since remember we are joining these two tables, right? And once the two tables have been joined, the system has access to 2 copies of custom ID. So when you just put custom ID right here, the system is confused. I can fetch customer ID from the orders table. I can also fetch custom ID from the customers table. So can you be more specific? This is just, vague, it's ambiguous. And that's why we step in and put this reference. When you now say orders.custom ID, you're now telling the system here, the version of custom ID I want is that from the orders table. So you see that this is not descriptive, this is more descriptive. This is just vague. This customer ID could come from the orders table or it could come from the customers table. But by putting the table reference next to the ambiguous column, you clear the ambiguity. The confusion is cleared out. You see, this is the system now understands the customer ID. Each time the customer ID from the orders table matches the customer ID on the customers table, then such a row should be placed in the result, the output. See, and if I execute this, and if you notice, stay on each row. You see, if I stay on this first row, this customer ID right here, this is the version from the customers orders table. That's the first table, orders table. The first table in the join is this. If I now scroll to the other side, on the customer side, you see that same value. This is it. And that's the practical implication of this on clause. So for each row, the customer ID from the orders table will always match that from the customers table. See that? So this is not something you should do. Sometimes you're dealing with a mutual column that has different name. Can a mutual column have different name? It's true. Right. So in that case, there will be no ambiguity. Right. But as long as your mutual column is having the same name across the two tables you're joining, you will always have an ambiguous error. And you have to fix it by adding the table reference. Right. So this is very important. So this is what was asked in that question right here. And let's see what we did right here. So they provided this just for us to complete this. See that? Now let's go to exercise 2. Let's see if we can do it. Yeah, this is still a concept on joins. Choose the correct join clause to select all records from the two tables where there is a match in both tables. Hey, this is very interesting. What join does this? You need that information. You see, what join does this? Read this again and tell me what join mimics this. What join will select all records from the two tables where there is a match in both tables? What join does this? Let's go back to this list. Tell me what join does that. What join will select all records from both tables where there is a match?
Is it the inner join?
Excellent. Inner join. There's no confusion on that. It's the inner join, you see. The inner join is the only join that will select all records from both tables whenever there's a match. You cannot miss that. You cannot confuse that, you see. Choose the correct join clause to select all records from the two tables where there is a match in both tables. Where there is a match in both tables. I always say try to visualize this with a Venn diagram. This is it. Whenever there's a match in both tables, this is a zone intersection. You cannot talk about left, right, or forward. You know? There must be a match in both tables. Hey, you're dealing with an inner join. Right? So knowing that information is very important because now let's fix the syntax. Select star from orders table. What do you do before you bring in the next table? You always declare the join type. You see that? If you go to our syntax, this exercise helps you to understand the syntax, right? That's why they're putting some blanks and also the theoretical construct as well. So when you state a table, before you bring in the next table, you always declare what the join type. So that's something to remember, and that concept will help you to get this right. So we've specified the first table orders before we specify the next table, which is what? Customers. If the name was not provided, if you go to the on clause, you can just get the name. It's orders and customers table. Right, that's also one clue. They must not tell you the two tables officially, but the fact that they have an on clause, this is a table reference. This is a column name. This is a table reference. This is a column name. You see? So this has been stated. We know the first table. Definitely, we have to declare inner join right here. Only an inner join will return all records from both tables where there is a match in both tables. I remember the last time I did this with the last students, a good number of students opted for the full join. Why? Because they got carried away and said all records from both tables. But then there was an extension whenever there is a match. That was a breakpoint. Right, the full join will give you all records from both tables. But when you extend it to whenever there's a match, you're back to an inner join. You know? So this is very important. So inner join. Now we can state the customers table. So this is a join between the orders table and the customers table. And now this completes the process on. You see the on clause carries the mutual column on the two tables. Right. So on the orders table, we're taking customer ID equal to the customer ID on the customers table. So that's why we have customers right here as a table. Are we okay with this? Now let's target this last one and we'll take a break. Please let's work on this. I want to make sure that we all get this right. Choose the correct join clause to select all the records from the customers table plus all matches in the orders table. Let's go back to this diagram and see which one matches. So we want to get all records from the customers table plus all matches in the orders table. All records from the customers table plus all matches in the orders table. Is anybody thinking about the inner join? He shouldn't be thinking about it. The inner join does not apply in this. The moment you're told to get all records from one particular table with matches on the opposite side, you're not dealing with an inner join. This is very important. The inner join is simple and straight, matching records in both tables. See, that language cannot be confused. Right, the moment you start reading concepts like getting all records from one table together with the matches in the other table, can somebody tell me what join type are we dealing with?
A left join in this case.
Yeah, you can achieve a left
Left
or a
or
right. See that?
right.
Yeah. Please, nobody should be thinking about a full join. In a full join, the two tables are prioritized. We are returning data across the two tables. But if you read this question again, we are prioritizing the customers table plus the matches on the opposite, which is the others. If you remember how we built that left join, I copied everything from the left table and dumped it right here. No question asked. All records from that table, and then including what the matches from the opposite table. And before this value could show up, I have first of all investigated if there's a match. That's how we added it. Those without a match, we dropped it. So this is an excellent description of either a left or a right join. Now, which is which? Of course, it cannot be both, right? So the system now has forced us to lean more towards one. Now, I want you guys to put the concept I've been struggling to explain today and tell me if it's going to be a left join or a right join. That is the test in this question, is to test if you understand the structure of a left join and that of a right join. There are just two options right here. Either we do a left join or we do a right join. Can somebody tell me which is correct? You have to follow the way the code has been built already in order
The
to
right
know.
join since.
So Alex is going for the right join.
And my thinking to that is because the on clause specifies the customers to the right, and yeah. Because I first of all thought the left join, but then again, if you say the left join, then that means the main table has to be on the left side. But since the on clause has already been specified in this case, and it shows on others.customer ID.
Okay, I think that's a good point. I also
Right.
want you to go back to the business requirement and read it again. So what table are we prioritizing? Is it customers or others?
As a customer, yeah, true.
Okay, so we are prioritizing the customers table. You see, it says all records from customers. Excellent. Now that information will now help you combine it with your previous reasoning, and you should arrive at the right solution. So if we're prioritizing the customers table, where is the customers table going to? Left or right? So since this position has already been taken, so they are kind of forcing you to do what? A right join. If you put left join right here, what are you prioritizing? Can somebody tell me what you're prioritizing if I put left join right here? We're prioritizing the table on the left hand side, which is others. Please, this is very important. You have to understand this. This is very, very important. If you go back to the concept we've been looking at today, this right here, if you go for a left join, priority table must be, this is non-negotiable. It's a must. It must be on the left side. If you're doing a right join, the prioritized table must be on the right hand side. This question has already given us the prioritized table. It's the customers. Why? We want to get all records of the customers. See? And then if you look at the way they've started the coding, they've started with the orders table. The orders table is not the prioritized table. It's on the left hand side. So you cannot do a left join, because if you do a left join, you prioritize the orders table, which is wrong. You want to prioritize the customers table. And so since the left position has already been occupied, the customers table can only go to the right table. And if your prioritized table is on the right hand side, you're forced to do what? A right join. If you stay right here and do a left join, you're prioritizing others. You're returning all the records from the others table. That's not what the question wants you to do. So this has to be switched to what? Right. And by so doing, the table on the right hand side is the prioritized table. Is it true? As far as the business requirement is concerned, yes, we want to return all records from the customers table. Since our customers table is on the right hand side, we must do a right join. This is very, very important. See, it all builds from this. Left join if the priority table must be on the left side. Right join, the priority table must be on the right hand side. Our customers table, by virtue of this code, is on the right hand side. others was already imposed on the left side. So we are left with just the right side empty. So we put customers on that side. And now you have to ask yourself, what table are we prioritizing? All records from customers. So we are prioritizing customers. And since customers is on the right hand side, we must do the right join. Are we okay? This is very important. Yeah. Let's take a break. Let's take a 15 minutes break. We're going to come back and continue. Right. I know it's a lot of key points I'm throwing out. Let's take a break. After the break, we can address a couple of questions. Right. But I think it's necessary we get a break at this point. Okay. See you after the break. Okay, are we back?
Yep.
Okay, so before the break, we're looking at left and right joins. Let me see what we have on the list. Yeah, I think we've done this ones. This is similar to what we just did. This is using the Northwind database and performing a left join between the customers table and the orders table. So if you look at this is a left join, so whatever table is on the left hand side, that's the prioritized table. So in this case, we are prioritizing the customers table. So it says select all customers. That's good. So customers is on the left hand side. We are doing a left join. So it's the two are in line. This always check this. If you're doing a left join, just look at the left table and know we are returning all records from that left table together with the matching records from the right table. That's how you read a left join. So once you spot left join, just target the left table and your conversation should begin like this. So we are returning all records from the customers table. All records from this table will return together with the matching values from this, matching records from this. That's the two zones you've taken care of, you see. So first, all the records from that left table will return. That's why the entire left table is green. All records is being returned. And then the ones we're getting from this side are just the matching ones. See? So easy left join, check out the table on the left hand side. You just have to know we are returning all records on the left table together with the matching ones on the right hand side. That's the orders table. Right. And this is what we get. The non-matching ones are those that you see, this is a company, these are customers who have not placed any order. There are two customers who have not placed any order. Every other customer has placed an order. See, you can see the customer's name and the order information, order ID, order date. So there are just two customers who have not placed any order. It's two customers right here. Right. So those are the customers that are going to be outside the intersection right here. This is the customers table. This is the orders table. These are those that have placed orders. These are those that have not placed any order. Right. So show each customer and the total number of orders they may have placed. Sort by decreasing order of total number of customers. So since we want to show each customer, right, we are prioritizing the customers to be table. So if there are 50 customers, all 50 of them should be displayed. And this is a good example of a left join, you see. Because if we do an inner join, we're only going to show customers who have placed an order. But they want to see each customer and the total number of orders they have placed. So we are not leaving out any customer. So this is a left join. The customers table is on the left hand side, you see. So we are prioritizing the customers table. We are showing all customers, right? So the customer has a company, the name of a company, and then we are counting the number of orders they have placed. So each time a customer places an order ID is generated for that order. So how can you count the number of orders? You can do a count on the order ID. And since this has not been aggregated, we have to put in the group by, see? And now this is what we get. See, so this will show you all the customers, right? If you go to the customers table, you can see how many customers were there, right? I can just put the select star from customers, or I can do count customer ID. Right, so I just want to isolate only the customers table and run so that we see the customers, total number of customers. There are 91 customers in the customers table. See that? So if we are showing each customer, it means that all the 91 customers must be shown. Right, so show each customer and the total number of orders they may have placed. So each customer, so 91 of them, and then we proceed to count the number of orders each has placed. Some customers can place no order, one order, or multiple orders. So it's going to vary, and that's why we're interested in counting. See, and now this counting has been sorted. See, if you remember what we did on the order by count descending, right? So we are ordering by the count of the IDs descending. So customers with the highest number of orders placed all the way down to the lowest. Remember, those two customers will never place any order, right? If you switch this left join to an inner join, these two customers will go away because an inner join will present this only customers who have placed an order, right? So these customers with 0 counts of orders, they will be kicked out if I switch this to an inner join, right? Please, when studying this, just try to switch and then interpret the results and make sure you understand why. So we are down from 91 to 89. 2 have been disqualified because those are the 2 customers who did not place any order. You see, and that's the goal of an inner join. One zone of interest, the intersection. You see that? For a left or right join, there are 2 zones. You're either in the intersection or you're outside the intersection for the prioritized table. Prioritized table 2, right join, you're either inside here or you're on this zone outside the intersection. You see, this is very, very important. So let's go back to the left join, right? So when you're studying, try to switch this and then interpret the results, see what changes, right? When you switch from left to inner and vice versa, see what changes and understand. See, we're now back to those 2 individuals who did not show or place any order. Why? Because this is a left join. We are prioritizing the left table, which is a customers table. We are showing all the 91 customers. See that? Right. So I just want you to create time and go over this. Right. Now this brings us to the right join. Even before getting to the right join, we've been seeing that all the questions that we've solved above with the left join, we can solve it with the right join. But you have to pay attention to the position of the table, the prioritized table. Right. So retrieves all records from the right table with the matching records from the left table. So first, we are getting all records from the right table. You see the entire right table is shaded. Right, so we get everything from the right, including the matching records. So which records from table 1 will show up for a right join? They must have a match. So all records together with the matching from the opposite table. The opposite in this case is table 1. That's how you frame this. See, this is very important. Right, inner join is kind of very straightforward. It just has one requirement: matching records in both tables. Now from there you can understand what the left and the right will do. Full join is just combination of both left and right. It's just, if you imagine these 2 diagrams move closer towards each other, they're going to generate a full join. So a left join plus a right join is a full join. So full join, you're just projecting all the records across the 2 tables, matching or non-matching. You see, right? So right join, in this case, I'm doing a right join. The prioritized table is table 2. This is very important. The moment you see right join, just go to the right hand side. So we are prioritizing this table. So we are returning all records from this table together with what? The matching from table 1. There's no condition on this table. That's why it's called a prioritized table. The only condition on this table is that it must have a matching value on this. And that's how you put this together and define it. If I go to that W3 schools, I just want us to visit the definition for, it should be right here, the definition for a left join. And you see that same logic. This is Sorry, we did left join. Let's do right join. The right join keyword returns all records from the right table, table 2, and the matching records from the left table, that's table 1. You see that the condition is on the right table if you're doing a left join. So we are prioritizing the table on the right hand side. So all records from that table needs to be displayed. And this is very, very important. You see. Now let me see if we have a couple of examples. So it's just a repetition of what we did above. Right. So the following SQL statement will select all customers. You see that? All customers and any orders they might have. See? So if you're doing a right join, make sure that the customers table is on the right hand side. Clearly you can see right here. Right. So the table on the right hand side of a right join is the prioritized table. Since we want to prioritize the customers table is on the right hand side. This must be a right join. Right. This is very important, and that's how we get this. Why are these two customers showing up even though they have no order? It's because we are prioritizing the customers table. So we are showing all customers, even if they have not placed any order. You see, if I switch this to an inner join again, these two customers will go away. Right. Inner join will only focus on the customers who have placed an order. Right. That's the intersection. Strictly the intersection. Right. Okay, now show each customer and the total number of orders they might have placed. This is a repetition. Above we've solved it using the left join. Now we're solving it using the same question we're solving using the right join. But take note, we've swapped the positions of the table. Customers is on the right hand side. We must do a right join because the table is prioritizing the customers table. Show each customer. Right. So since customer has already been placed on this side, guess what? This must be a right join because customers table is on the right hand side. And that's that process right there. So we're showing each customer, that's a company, and the total number of orders they may have placed. So those two customers with 0 orders are showing all the way at the bottom. Right. And they're showing because of a right or a left join. They will not show in the case of an inner join. Okay, so this segment of business logic is a little modification we're going to do. Let me just read this question. The sales manager at Sam's Club wants a list of all customers who have never placed an order. I want you to notice something. The requirement has changed a little bit. Before, we used to be interested in those that have placed an order. The intersection, those that have placed an order or not placed an order, we do left or right join. But this is different. Those that have not placed an order. So this question right here, we're going to pass through a left or a right join, and then we remove this list, this area right here, so that we are left with this. These are those who have never placed an order. So first step, we do a left join, and then we figure out a way to remove the intersection. And if you do a left join and you remove the intersection, you will be left with something like this. Let me see if I can draw this scenario. Right. So imagine us removing this again on this side. So we have table 1 and table 2. Imagine we remove the intersection. I'm focusing on left join. Remove this intersection. So this will be the shaded region of interest, this part. So if 1 is the customers table and 2 is the orders table, customers who have never placed an order, they will be in this zone. So you realize that we've taken out the intersection. So first, for you to move from this to this, you have to first of all start by building a left join, and then you add a condition. You add a where clause so as to get rid of this. Now we focus on the zone. These are customers who have never placed an order, and that's the goal of that question. Right, let me go back to that. Right, so that's exactly what we're going to do. Right. So first thing we're going to do is perform a left join, and then add a condition which will remove those that have placed an order, so that we are left with those that have never placed an order. So let's read the question again. These are all customers who have never placed an order. So the business question is only show customers with no orders, right? And what's the logic? If a customer has not placed an order, their customer ID will be missing. That's null in the orders table. Right, let me show you. Let's use business customer insights. Right, and this is something interesting I want us to talk about first before we get into. Let's explore the tables separately. Right, this has to do with the business logic. If a customer has not placed an order, customer ID will not show up in the orders table. Let me demonstrate that. This is the orders table. This is the customers table. It contains what? Customer information. You see, customer ID, first shop, age, and you see this is customer information. On the orders table, what do we see? We see the order information and also what customer placed the order, customer ID. So if a customer has never placed an order, this is what the business logic is saying. If a customer has not placed an order, their customer ID will be missing in the orders table. So if a customer has never placed an order, if I go to the customer ID on the orders table, their ID will not be listed right here. See that? That's a very important thing. So if I join the two tables, this is the join right here. Through a left join, we are showing all customers. Left join. Customers is on the left hand side. Left join is showing all customers. So if I run this part, I want you to notice something interesting. You see these two customers, those are the two individuals we saw last time. They've not placed an order. And that's what this question wants us to show. These two individuals right here, they have no order. See, so the columns from the orders table is all null. They are not interested in those that have placed an order. They're interested in only these two customers. So how can you get rid of all of these people who have placed an order? Let's get rid of this. And we end up having only those that have not placed an order, these two. Right. For you to solve this question, you need to add a where clause. You see, this is it right here. You have to go to the opposite table, which is the orders table, and you make sure that the customer ID is missing in the orders table. So if a customer has never placed an order, you will not see their customer ID listed in the orders table. You see, so you must go to the opposite table, which is what the orders table. This is very important. And so you see what we're doing, we are testing the customer ID in the opposite table, which is the orders table, and we are making sure it's null. If you add this condition, you end up having those two customers who have never placed an order. If a customer has placed an order, then their customer ID in the orders table cannot be null. It will have a value that's indicating they've placed an order, you see. And that's the basis of this. Has this person placed an order? We go to the customer ID on orders, we see it right here. That's the basis of the mapping. Right, these two, they have no matching customer ID, so the two have never placed an order. So how will you code that in SQL? You're going to put where the customer ID on the orders table, please take note, is the opposite table, is null. So give me those individuals whose customer ID are not present in the orders table. And how do you code that? Where the customer ID on the orders table is null. That is the modification you're going to add right here. So please take note, we are first of all doing a left join. We'll return all the customers and any orders they may or may have not placed. You see, those that have placed the order right here, those that have not placed the order right here. Now we want to dismiss this zone. This is the intersection. That's why I started by drawing a diagram to show you those that have placed an order. And then if we go and wipe out this intersection, you are left with those that have never placed an order. So we use a where clause to remove this, right? And the where clause will be where the customer ID in the orders table is null. See? And these are the only two customers where their customer IDs do not show up in the orders table. It's null. And so if you add that condition, this is what you get. These are the two customers who have never placed an order. So sometimes the project requirement could be different. You could be looking at only customers that have placed an order. You have to always remember that's an inner join. We could be looking at customers that have placed an order together with those that have never placed an order. That's a left or a right join. You could be asked to only return the customers who have never placed an order. You have to go through a left join and add the where clause to kick out those that have placed an order. And the business logic is very simple on this. If you're a customer and you've never placed an order, then your customer ID will be missing on the all orders table. You have to go to the opposite table. Right. You have to realize that you cannot put c.customer ID. Every customer has a customer ID. So this is not true. This will never be missing. Customer ID is a primary key on customers table. That's why I keep insisting that this condition must be based on the opposite table, the non-prioritized table. In this case, the orders table. See? And this is it. So you see the two steps we did. First, you build a left join. Then you impose a condition on a key column in the opposite table. The opposite table is the orders table. If a customer has never placed an order, their customer ID will be null in the orders table. That's why we put where customer ID in the orders table is null. And that's how we return those two customers who have never placed an order. Are we okay? All right, this will need some practice. You really have to sit back and study this. Let's do the same for presentation. Let's look at those customers, those students who have not been assigned to any project. Remember, we have two tables in the presentation database. We have the student table, we have the project table. In the student table, we just have the list of students. Project table, we have the list of projects. Some students are assigned to projects, some are not assigned to projects. You see? So if a student is not assigned to a project, then their student ID will be missing in the project table. Every student ID will show up in the student table. You see, every student has a student ID, right? So you test on the opposite table, right? So if you go now to the project table, when you don't see a student's ID listed on the project table, it simply means that student has no project. So this is a project table right here. Any student who has an ID showing up, they have a project. It tells you that this project right here, creating databases in SQL Server, is assigned to this student. If I go to the student table, I'll find that student, ID 122. This is the student right here. See that? All right, so that's how that's the logic, and that's the same thing I capture right here. So only show students with no projects. How many students do we have in total? Let's run this. We have 41 students. Of these 41 students, how many have not been assigned to any project? Print out a list of those students that have not been assigned to any project. This is the objective right here. So what is the business logic? For students with no projects, student ID in the project table is null. Same thing we did right here. If a customer has not placed any order, the customer ID in the orders table will be null. And so it's just a matter of adding a where clause. You see? So this is the join right here. You do the join between the two tables. And each time you see a student ID from the project table being null, that student has no project. It's true. Priska has no project. If you look at the project ID is null, project title is null, the student ID from the project table null, and so on. You see, this is typical characteristics. You can either use the student ID from the project, or you can go with project ID. If a student has no project, then the project ID is null. You can put where project ID is null. So either this solution, or you can use the project ID is null approach. It's still gonna work out nice. I can just put here where project ID is null. See, either project ID, project title is the same kind of scenario. This will hit the same result as the one above. See, these are 21 students who have not been assigned to any project. You see that in all columns from the project table is returning an empty null, blank. You see, this is very important. These are the list of 21 students with no project assigned. Out of 41 students, 21 have no project. You see that? So you can easily achieve this either by using the project ID or by using the student ID, but make sure it's from the project table. Right, and this is the same list you get. See that? So these are little tweaks that they can ask you. You have to understand how to start. When you draw the Venn diagram, left table, left join, you get the two zones. If you remove the intersection, you're left with this. And what does this represent? The students that have not been assigned any project. This is students that have been assigned projects. These are students that have not been assigned projects. If you are asked to return only students that have been assigned to projects, you're going for an inner join. If you're asked to return students that have never been assigned a project, you must do either a left join or a right join, and then you add a where clause so as to focus on this part. And that's exactly what I'm trying to expose you guys to. This is a modification of the left or the right join by just adding a condition, right? So you can clearly see the students that have never been assigned to projects, right? For students that have been assigned to projects, you have to do an inner join. See that? Again, I want to repeat this like 3 different times. This is the same logic again. We have projects and managers. The goal of the project management database is to track managers and also the projects they're working on, right? So if you explore those two tables separately, you will realize that the managers table is just giving you manager level information, right? While the project table contains the actual projects. See, manager information like the manager ID, first name, last name, gender, is certified. Does this manager have a certificate in project management? If it is 1, the answer is yes. 0 means no. So is certified. 0 means no. Yes means 1, or 1 means yes. See that? And you can do the same on the project, right? So I want to repeat this across different scenarios, but the same idea applies. You see, this is a project table. Now these are the projects that the company has. See, and for each project, you can tell what manager is working on the project by looking at the manager ID. So this project right here is lab facilities. Start date right here, end date, location. It's been assigned to this manager, right? You see that? And now you begin by joining the two tables. We're going for a left join so that we get all managers that have projects together with those that don't have any projects. An easy way to identify a manager that has no project is when you start seeing nulls across all columns from the project table. You see this manager right here doesn't have a project. You see, there's no project title, no project name, no project type, no start date. You see, this is just a clear indication that this manager has no project. See that? So if you're a manager and you've not been assigned a project, then your manager ID will be null on the project table. This is null, null, null. Or you can do the project ID will be null. In fact, you can use any key column on this table will be null. See? So that's the logic. You see, I choose to use the manager ID on the project table will be null. Some other person will use project ID. Every project has a project ID, right? So if the project ID is missing, then that project does not exist, right? So I can switch this and say project ID is missing, right? And this is the list of managers. There are 13 of them who are currently not assigned to any project. So all these three, I think these are three business scenarios we've seen. They all have the same idea. We all go through a left join. You can also solve this by going through a right join, but make sure you switch the table position. So you first of all go through a left join, get the two zones, and then add a where clause to dismiss one of the zones, and you're left with the zone of interest. You see? All right, this is really interesting. And all of these questions, yeah, these are things that you can just check out. You'll find them on the Q&A document, page 17. It's this document right here. So if you go to this question and answer document, and you just type 17, or it takes me to 17 already. 17 right here. Right. So these are questions on joins. Inner joins, you find them above. Inner joins should be above. These are questions on inner joins. Right. You can just practice them, just read through and practice them. On Wednesday during the lab, I will show you how to extend a join. I think we've covered a lot of materials today. I don't want to bring that concept. You see that this is a join between the customers table and the person table. And then we are adding the next table, sales order header. It's just to add another inner join, state the table, and then the on clause. So I don't want to introduce that today. That's too much today. We've covered some very key concepts. I want you guys to have a time to review them. And then when we are back, we can, during the lab session, we're going to see more questions. Right. So when you're studying this, please focus on these three business scenarios where we are using this business logic on the left joint. This is very important so that you understand the implication of this where clause, what happens when you add it. Right. So there are three scenarios. I want you to create time and go over the three scenarios, understand them. If you have any issues with them, we're going to look at examples during the lab session on Wednesday. We're going to close for today with the full join. This is pretty much an easy one. It's just the same join syntax. The only difference is we are putting a full right here. Right. Some other people do full outer join. They kind of state those three keywords, but it doesn't really matter. If you just put full join, it's good. Some other persons will do full outer and add the keyword outer. This is too much typing, but it's still okay. So either you do full join or you do full outer join. It's the same. So for example, this is a Northwind. Right? You want to get all customers and all orders. So full joins are helpful when you just want to access the records across the two tables. You don't want to delete any record. You don't want to kick out any record. So all the records from the customers table, you want to have access to them. You also want to have access to all the records from the orders table. You see, and that's why if you look at the Venn diagram, the two tables are green. So you're getting everything. You're not kicking out any rows. The inner join, left and right joins will kick out rows that don't have matching records. Right. But this one will preserve it to show everything. No rows will be kicked out. You see? So sometimes you're doing an analysis, you're not very sure. To be on the safe side, you want to keep all the records and you proceed to analyze them the way they are. Right. But sometimes a business requirement is clearly stated. We don't want these records to show up. Now you can use either inner, left, or right joins to target those. But if you just need the general picture or records across the two tables, nothing being thrown away, an excellent example will be a full join. See? So I want to get all customers and all others. See? I am not adding any condition for the customers or any condition on the join on the others. I'll just go for a full join. And this is the Northwind database. Right. So this is the point I was trying to make. You see, some people will just type full join right there. Alternatively, they will just put full outer. So yeah, if you see a colleague at a company doing this, don't be confused. This is just too much typing, but this does the job. Remember, if you remove this, you're back to an inner join. That's the default join, you see. Right, so this is a full join. You're just getting all the records from the two tables. See, nothing is thrown away. See the number of records. Or you can do full outer join. That's a full name right there. It's the same thing, you see. Right, I don't want us to go to multiple joins, so we can stop here for today. I want to give you time to study this again. We're gonna meet on Wednesday during the lab session, and we can go over more projects on joins. This is a very important topic in SQL. Right, it's difficult to go to an interview and you don't have a question on joins. They want to know if you can join two or more tables together. This is very, very important. Right, and always remember Venn diagrams will help you. Whenever you're in doubt, read the question and try to build a Venn diagram and see what region is being targeted. From that region, you can easily know if you're going to do an inner join, a left join, right join, or a full join. Are we okay? Okay, we're going to stop here for today. So next Wednesday, during the lab session, we're going to extend to multiple joins. But I will send out the project for you guys to work on. Right. So see you on Wednesday. Please, for those who missed the lab session, the class of yesterday, the recording is available in the email. Try to watch it and together with today's lecture, so as to have a complete picture of or complete understanding of the joint concept. Right. Okay, guys. See you on Wednesday.
Okay. Good night, sir.
Good night. Yeah.